based FTP program. So, a very good afternoon to all, one and all, in this last session of the FTP of day second. Now, I would like to call Ms. Tanya for the introduction to the brief profile of Mr. Saxena, Dr. Saxena, sorry.
Much, ma'am.
Yes.
To all. Saxena sir has received BTech degree from Kamalai Nehru Institute of Technology, Kanpur, Uttar Pradesh in 2010 and has received MTech and PhD degrees from IIT Roorkee in 2012 and 2017 respectively. He was a postdoctoral fellow with the Tel Aviv University, Israel in 2019. Currently, he is an assistant professor in the Electrical and Instrumentation Engineering Department at Thapar University of Engineering and Technology, Patiala, Punjab. He is a recipient of IETE MN Saha Memorial Award for the Best Application Oriented Paper in 2000. Ma'am, was I audible?
Yes.
Okay. Over to you, sir. Kindly enlighten us with your knowledge.
Okay. Thank you, Tanya. And first of all, I would like to thanks for the invitation to Professor Pankaj Madan, the director, and Professor Gajen Singh Rawat for organizing an important FDP. It's really a very important FDP because the topic is very appealing as well as it's an important not only in current scenario, but it is always a fascinating for all the persons to look what actually is the robotics and how it works and what actually and why we are studying the robots. So it is always a fascinating thing for not only for the engineers but also for the school going kids and everybody. Every time they are trying to make the robots and trying to build some sort of anything automatic that can work and replace a human thing like this. Okay, so anyways, so thank you so much once again. And now my topic is here the robot control. So in this robot control, we will understand what actually is the robot and what is control, and together we club it and we will see what actually is the robot control. So before going towards the robotics and in detail, we'll first see a video so that it will make you ponder upon what actually the robotics is. So let's see. I guess you are able to see my web screen, right? Okay. So are you able to see my videos?
No, sir. No.
Anyway, I will once again share it. Now you are able to see my video.
Yes, sir.
Yes, sir.
Yes, sir. Okay.
Yes, sir.
Okay, so I think you have enjoyed this video, and the interesting thing in the video is everything is automatic. So everything is automatic, right? Yes. So now you are looking at my PPT, right? Are you once again able to see my PPT?
No, sir.
No, sir, the screen is black. Yes, now it's visible.
Now it is okay?
Yes, sir.
Yes, sir, it's visible.
Visible, sir, but that is not PowerPoint. PPT.
Okay. Now it is okay. Yes?
Sir.
No, sir, again the screen is not clear.
We are seeing your web browser only, sir.
Could you please share your screen again so that we are able to see that?
Now it is clear?
Sir, it's coming. Yes, sir, it's clear now.
Okay. Okay. So this was a video which you see in the robot. So everything was automatic and they are playing football, they are able to catch the ball, they are like flying in the air. So everything is automatic. And these are the role of automations. So this up to this level, people have reached to design the robots. Anyways, we'll see what actually it is. So throughout my slide, we will be covering the robot terminology. Then we will see how robotics in COVID-19 is playing an important role. Then we are reading a little bit about the robot dynamics, what it is. Then we are moving towards the control, and the control is PID controller. And afterwards, we will see the future directions and where the recent trend is moving in order to evolve more robotics technology. Okay, so the first very question is, can anything operate the process with better accuracy and precision than human? The very first answer is yes. And how? It is through automation. So what is automation? It can be defined as a technology that uses program commands to operate a given process combined with feedback of information to determine that the commands have been properly executed. Right? So this is a very standard definition of automation. And automation is a technology. And in a layman language, I can say the control of a process by means is called automation. So everything is by automatic, it is called automation. Okay. So how do we perform automation? The again answer is robot. And again, when we saw robot. So what does a robot means? So robot is a computer controlled machine that involves automation. So robot is just like a machine. It is basically controlled, and the control means is computer, or nowadays it is a mobile. And through this connection, we are actually doing some sort of automatic processes. All right, so this is the literary meaning of robot. Robot is an automated machine, and robot has a human-like characteristic. That is why we call it as a robot, because it will have some characteristics that can mimic the performance of a human. For example, a mechanical manipulator that is designed somewhat to act like a human arm with wrists and hands. So what is mechanical manipulator? You can see this one is the mechanical manipulator. So what it is? A human hand. How? This is my elbow this is my shoulder, this is my wrist, and this is my end effector, or you can say a gripper. So these are the functions or the key components of the mechanical manipulator, and it will behave exactly like a human hand because the behavior is like a human hand. Meaning of a robot. So the robot is a term which is not an English word. It's a Czech word and has been derived from word called robota, and robota is workers. So robota means workers, and in 1950, when the Karl Capek uses this term in his play Rosium Universal Robots, then this word get a very popular, and we started calling it as a robot. And the purpose of that play, which the Karl Capek I mean, uses in the play is to show that there is something which is better than human, and a human race is evolving, and which can work in a very better way than the man. So it has an intelligence completely equal to the man, or it may be a more intelligent than a human. So he want to play a fiction like thing in which he said that there is one machine which has an intelligence, and that intelligence can overrule the world and can overrule the human race. So that is why we are very fascinated towards the word called robot. Anyway, but if something oversees the human intelligence, then it will definitely be a threat for us. And to avoid such type of threats, what is yes, okay. So in order to improve the that the robot should not supersede the human, there are some laws and which have been framed by Isaac Asimov, and he said that the robot should not supersede the human race. And in order to prevent this type of working, this such type of research, there are three laws of the robots, and these laws are basically for the regulation purpose of the robot, so that no one can make a robot that can rule the humanity. So what are those rules? The rules are: first one, a robot may not injure a human being or through inaction, comma, allow a human being to come to harm. So if any human being come to harm the robot, it will not react it, simply surrender it, and it will not kill a human, or it will not give any harm to the human. The second is a robot must obey the orders given it by human beings except where such orders would conflict with the first law. So it has to obey the human orders. It should not disobey the human orders and do according to its own will. That is not permitted in the robot, and it is a law. The third is a robot must protect its own existence as long as such protection does not conflict with the first or second laws. So until unless the robot is not harming any human, it can work, or it can show its existence, it can protect itself from some certain type of disturbances. So these are the three laws which are framed in order to prevent its overseeding or superseding the human race. So anybody who is creating a robot, he should follow these three rules. Okay, so are robots necessary for us? Robot? Yes. The answer is because the robots are primarily used in where we have some chemicals and we have to build those chemicals, we have to pack those chemicals. So for packing and packaging and motion and controlling the temperature, or manufacturing those hazardous chemicals, it is utmost necessary that we must not enter into that particular region. Only robots will handle those activities. The second is nuclear plants, where we have a nuclear reactions, nuclear fusion, nuclear fission, and these are radiations which we have to protect ourselves from in order to avoid any disaster. There, the robots work. Space technology, for example, we have a Mars mission and a lunar mission where we have a land rover and it will move to the Mars and it will detect the quality of the soil, quality of elements present over there, where the human is not actually accessible and it cannot move to that particular region. So that is why we use the space technology. The fourth is the war grounds, where we have to dispose the bombs, where there is a human threat. We should not go into those particular areas. Our robots will work well and we will definitely get our work accomplished. So these are the very typical and very popular techniques or applications where robots are really necessary. But one more necessity arises, and that necessity arises in our present scenario, that is a COVID-19 scenario. So what COVID-19 scenario is, there is a magazine called Spectrum, and the Spectrum is published by a very reputed organization called IEEE. So IEEE is the leading organization in the world. The IEEE full form stands for Institute of Electrical and Electronics Engineering, and it actually lays the foundations, lays the protocols, lays the uh, technologies for any type of electrical or electronic component, as well as it is also serve as a research group where we can present our research, they publish our journals. So it is a very important organization in the world, and that is IEEE. And the most popular work or the recent work generally publishes in the Spectrum magazine. And we are very uh, excited, as well as we are very lucky that in the present edition, that is of October 2020, the cover page was this, as you are watching on the screen. And the content written is, COVID-19 has galvanized tech communities. The tens of billions we are spending on vaccines, antivirals, tests, and robots and devices transforming how we will respond to future outbreak of infectious diseases. So this is the very crucial and very important activity, and that is the robot, which is playing a frontline warrior in the COVID-19 situation. It means robot is a very interesting, very important, and the the demand of the present to work on it so that we can save from the infectious diseases. So as of now, we can say that robots and essential workers, let us see how they are essential to us. The first is sample collection of the sap. So what is sample collection of the sap? It is the most typical thing which we have worry about, and people generally frightened why we should collect the samples, because it is infectious and one authority who is collecting the samples will also get infected with the those sap. So here the robots play an important role. Let us see how they play an important role, and we will see a video so that you can understand what actually it is. Are you able to see my web browser? Yes?
Yes, yes.
Okay. So we'll see this. Okay, so basically you are able to see the video, and in that video you saw a swab collection robot which actually enters the swab into the nose, and through that stick they collect the swab and put it into the sample collection box, and it is actually done with the help of robot, right? So are you able to see PPT?
Sir, did you play the video? Because I was not able to see the video. I just saw your browser.
Yes, sir. Video was not played actually.
Yes, sir. Video is not played.
Sir, video is not played, sir.
Okay, I will once again play the video and you will see them.
Oh, it's
Right?
playing, sir. Video is playing now.
Okay.
Now it is.
Yes, now it's working, sir.
I hope you have watched the video and you get a glimpse how important the robot is in the COVID-19 situation. Okay, so this was the very first application in the COVID-19 situation. The other is disinfection of the hospitals and wards and rooms for the COVID-19 patient. So we actually uses the robot, and that robot has ultraviolet facility, and they can emit ultraviolet rays that will kill the viruses. So this is the another application of the robot, the disinfecting agent. The third, to transfer the medicine from one ward to another, one room to another, because the hospital authorities sometimes frightened to enter into the room of the infectious people. So for this, robots play an important role, and of course they are serving as a boon for us. Let us see how they are delivering the. So I think you have again watched the robot. Yes. Okay. So again, you see how crucial the robot is for the delivery of medical supplies. The next is contact-free recording of a patient's in the medical parameters. So whenever you have to read the medical parameters like pulse, oxygen, something from a patient, then we have a robots. They will enter into the ward, they will collect the data, and they will transmit it to the doctor so that the doctor can monitor the situation of a patient, right? So you can see that these are some critical applications of the robot in the COVID-19 situation. Now, before moving on towards some more complex terms, we will learn few definitions, and based on those definitions, we are trying to use those words to understand more about the robot control. So there are few terms. The first is process. Process is the device or a plant or a system under the which I actually want to control. Then we have an actuator. The actuator is a device that causes the process to provide the output, the device that provides the motive power to the output. So actually, this is the main component that actually drive the plant. All right. So this is actuator. We call it as DC motor. So DC motor as an example is an actuator. Why? Because it uses an input voltage as a control variable, and because motor, it will have some motion like activity. So by consuming the power, it will rotate the shaft. So this is actually in terms of actuating the process. So we have DC motor as an example of an actuator. We have control system, an important thing. So control system is what? An interconnection of the components forming a system configuration that will provide a desired response. So what do you mean by control system? So control system is a group of components and they are designed to obtain a particular or a desired response. For example, if I am going to build a robot that will move in a straight line, so the overall whole robot with the complete power accessories, with electronic components, with mechanical components, it is collectively called a control system. Okay, so this is a control system. As of now, we have read the control system and we have a robots. Now, what is the main components of the robots? How we can build the robot? So before building a robot, we need to understand the dynamics. Dynamics means how the system behaves, how the system evolve with the time. So let's talk about a very simple example that we have a robotic arm. So what is a robotic arm? This arm, and in this arm we have one arm, this is another portion, and both the portions are connected at a joint, and this joint will move. But how it will move? It will be actuated by something, and that something part is by DC motor. So this is basically a DC motor which actually drives the system. So DC motor is an actuator, and in the robot we have two links. This is one link and this is the another link, and you both the links are collected with the joints, right? So this is one link and this is another link. So these are connected with the some movable thing which is called a joint, and joint moves due to facility of a motor, and here we have a motor placed in it. So this type of robotic arm is generally known as a manipulator, or sometimes it is called as a mechanical manipulator. All right, so manipulator. So now the our objective is to model the robot behavior, how it will behave. We have to study its behavior. And the key components which we are to focus on are conceptual control loop for one joint, how you can control this one joint, what is the actuator dynamics, how the actuator make the robot to move it. This is another learning, key learning. The third is dynamical model of a robot with one joint. So in this talk we are only focused on the one joint robot, so that you will have a some flavor of how the robotic arm moves and what actually the components which we focus on and how we design a controller. So we are talking on the actuator process, and actuator is nothing but the DC motor. And here we are taking as a permanent magnet DC motor. And I hope we that DC motor is a very common component, and we everybody try to study it. And whenever we are in, we must know what actually the DC motor. So in a DC motor, we have a current carrying conductor, and that conductor is placed in a magnetic field. And when magnetic field is there and a current conductor is placed in a magnetic field, then it will experience a force, and that force is actually dependent on the current I flowing into the conductor and the flux which is actually evolving through the poles of a magnet. So the force is basically I cross phi, where phi is my magnetic flux and I is the current, and this cross symbol is basically the vector multiplication, or it in terms we call it as a cross. So we have a force because it is a vector quantity, so we have a direction here. Of course, because of the force, then there will be a torque and my conductor will try to move. So the torque basically depends on the current I. And here we have a current I. So tau m is directly proportional to current I here. And these are the constant, which we sometimes call it as a proportionality constant, and this constant is k multiplied by the magnitude of the current multiplied by the magnitude of the flux. So because these are the magnitude, so we consider it as a constant term irrespective of, forget about the unit because unit will be according to the torque. Okay. All right, so we have DC motor, and the DC motor will produce a torque, and the torque, through torque we have some sort of a motion. So whenever conductor moves in a magnetic field, the voltage VB is induced. We know that VB is a back EMF voltage, and that back EMF voltage is induced, and it is proportional to the velocity of a conductor. So basically it tries to oppose the motion of a conductor, and you know about the Fleming's laws. So with those laws we have some sort of a friction over here. So back EMF is directly proportional to the velocity, and that is velocity is nothing if I have a theta, which is my angle. So velocity will be the time derivative of my angle. So VB is directly proportional to the velocity of the angle covered by the conductor. So these are the three dynamics or the laws through which my DC motor work. Now what happens? I have a motor and the motor is rotating, and because it is rotating, we have added a shaft. You can see here a shaft. So a shaft is just like a rod. So when our motor rotates, let's say if it is rotating in this direction, then my shaft, of course, let's say the motor is rotating in this direction. So my shaft will also rotate in this direction. So because it is rotating, and we know that we have some moment of inertia associated with the rod, we have torque. So torque will give the moment of inertia, and it will produce some rotatory type of motion in the shaft. And because we have a DC motor, we have a current flowing through the conductor. So I can expect that because it is a conductor, there must be some sort of a resistance over here, some sort of a inductance over here. And because we are giving power to the DC motor, the power is obtaining with the help of a voltage V. So we actually give a power to a voltage through which current will flow through the circuit, and because of the current through the conductor, torque will be produced, and torque will make the shaft to move in a particular direction. So this is the DC motor, and if we see the relations, then we have, if we apply a Kirchhoff law here, so we know that there is a Kirchhoff law, and because it is a closed loop circuit, the Kirchhoff law will say that this is an inductor. So the voltage across the inductor is L, time derivative of the current L, plus voltage across resistance VR. So this is my VR. Voltage across inductor is VL, and this is my VL. So it is VL is L di by dt plus VR, and that is equal to the current voltage, and there again an opposite voltage back EMF. So it is equal to the V minus VB. Okay, so this is a simple Kirchhoff's voltage law, and with this we get this relation. So this is one dynamic of a system. Now we know that the back EMF has the following relationship as we talked in the earlier slide. Next, we have a torque. We also again read that torque is directly proportional to the current I, and this proportionality constant, the complete proportionality constant, we replaces with the help of Km. So we have tau m is equal to Km into I. So now we have three relationships in order to make a shaft a motion. So first relationship is with Kirchhoff's voltage law. The second relationship talks about the back EMF. The third relationship is because the motor will rotate, and so we have the torque, and torque will actually produce. So these are three relationships through which we can cover the motion of a single joint manipulator. Now, because we have a shaft here, you can see a shaft. This is a shaft, and we will make a complex shaft because it is not a simple rod. So we have a rod, and this rod is, let's say, this is my rod connected with the DC motor. Of course, rod has gears, so this is my gear, and because it is moving in this direction, then gear will also move, and with this gear we have another gear, and again there is another rod. So in turn, if this is motion, giving a motion, then it will also rotate. So because of the and teeth, here we have a teeth in this system. So with if this will move, then this will again move, and therefore this rod will also move. So we have a train of gears, and with this, with a motor, you can rotate a lot of joints. All right. So let's talk about only a single joint. So we have one rod, the another rod, and both the rods are connected with the gear, and we have a gear ratio of R. So this is my gear ratio. It means if this will move a theta m angle, then the another rod will move theta s, and the relation between theta m and theta s is R, which is nothing but the gear ratio. So this is a gear ratio. I hope you have simply learned about the gear ratio. So it will actually transfer the work from one rod to the another rod with the help of a gear. So we have a gear, and we know that in an ideal condition, we don't have any friction, but in practical, we have a friction due to air, due to viscosity of the rotation. So we have a friction, and because we have a friction, we will apply another force, that is a frictional force. If this is my motion in this direction, then friction will move, cause the motion to this direction, and this motion is directly proportional to the viscosity of rotation or viscous force constant, that is Bm. So it is exactly simple to the linear friction, because in linear friction we know that if we have a plain road, and we have a block, and if I give a force in this direction, then friction will create a force in opposite direction. And if, let's say, F is my friction, so this force is equal to some constant into velocity of a block. So the frictional force is directly proportional to the velocity of the block. And here we have a friction coefficient. Similarly, in the rotation, we also have a rotationary friction force, and that is again dependent on the acceleration, or sorry, on a velocity. And this velocity is nothing but the angular velocity, and beta m is constant. Okay, so this is a friction force, and with this friction, we have this sort of an arrangement. Now we have to write the equations of motions. So basically, this is a lump model of a single link with actuator oblique gear transmission. And in terms of motor angle, the equation of a motion becomes this one. So this is my equation of motion. How it comes? Let's talk about this particular equation, the very first part of the equation. So very first part of the equation, we generally know that the total torque or the torque net is actually moment of inertia, which I say by I, or sometimes we call it with the help of J. Here we call it with J into angular acceleration, that is alpha. So we call it J, and alpha is the angular acceleration. It is double derivative of the angle theta m. So we have this. Now what is total torque. The total torque is because the motor is moving, and due to the DC motor power, we have a is tau m, and this tau m is there. We also have a friction force which will cause the motion in this direction. So this is the total torque minus friction. This is a friction, and of course, because of the here we have another load. We call it as a load or another rod. Because of the friction and inertia, it will also oppose the motion of this because of the gear. Because gears are attached, we have a load, therefore it will again oppose the motion. So what the motion is, if say this produces a torque tau L, or it is a load torque, I will call it as a load torque. Because of the load, there will be a torque, and load torque is there. So when I will transfer this load torque through a gear, then it will be divided by the gear ratio, that is R. So we have a tau L and it is divided by R. So this is again an opposite force which will be subtracted from the total DC motor torque. Okay, so this is force. I hope you have a little bit flavor about how you are able to actually obtain the equation of a motion. Okay, here we have a tau m, and we know that the tau torque is directly proportional to the current. So we replace tau m with the kmi, and rest of the portion is as it is. So with this, we are able to frame two equations. So this is with a two frame, and when there are two frames, then we have two equations. One is with the DC motor. This equation is of Kirchhoff's law, and because these are simple equations, then I don't think that there will be some sort of a doubt because it is from the higher end or from the engineering point of view. I don't expect, because these are the very basic equations, and I believe that in the +2 level or 10 plus 2 level, I hope all the people are familiar with such type of mathematics. So I tried to simplify all those mathematics, and let's see how it works. So this is the equation governing the DC motor dynamics, and it is again, and this is the equation governing the motion of. So basically, if I want to rotate a if I want to move a single link robot, so in a single link robot, there will be a DC motor which will provide a torque, and due to torque, there will be a link, and link will move. So how they will move? They will be moved with this equations. And this is the power produced by the DC motor. So I think this is a DC motor power, and this is a motion of a shaft, and these two things together and will make people understand how will my motion will be acquired. Okay, so basically, as of now, people will frighten to see these two equations, but you need not to worry about it, because these are, I will try to make it more clear, because these are simple differential equations. Why it is differential equations? Because of the presence of differentiation or differential part like this. This is one part which will make, this is another part, this is another part, this is another part. So these are the basically differential equations, and people do not know how to solve it. Anyways, we have a tool to solve it. So these are differential equations, and how we try to understand these equations, we make some we make actually the use of one standard tool, that is a Laplace transform, which will help you to understand how our system will behave and how you are able to create a control system. Okay, so next we try to make use of, or try to understand what actually is the Laplace transform. So Laplace transform is a tool to solve differential equations. So these were the differentiations and integrations, how you will solve it. We have a Laplace tool. What is actually a Laplace tool? So let us understand. So Laplace tool, let us define there is some function ft, and ft is nothing but simple an expression which is a function of a time. It means when we vary the time, there will be a function and the function will take the another values. Okay, so a function of a time such that ft equal to 0 for t less than 0. What does it mean? It is very simple, because when t is 0 means when we have not started any process,
Excuse me, sir.
we have our function
Excuse
f.
me, sir.
Yes.
Can you please start with the basics of DC or analog motors, because our students will not be able to understand this part. Rather, it's a little bit on higher side for me as well.
Uh,
Please,
uh,
sir, if you can.
Yes, sir.
okay,
It's very tough for understand, sir.
Uh, anyways, I try to make a lot of effort to simplify it for the school teachers. Well, anyway, we again, I hope I believe that you were able to stuck in these equations, right? So let's move on towards another once again to the DC motor part, and we'll see how actually it works, right? So let's take it. So I think that you all know the DC motor. So what is a motor? Motor is something which converts the electrical energy into the mechanical energy. You give some power to it and it will give you some motions. So when we have some motions here, it means that we are having some force, and that force will create a motion to the system, because DC motor is the most basic part of the robotics. If you are not able to understand the DC motor, then the whole robotics will be of no use for you. Very frankly, I am telling you. But anyways, so we have a DC motor that has power, and that power will actually be transformed into a mechanical motion. So here we have a conductor, and the conductor is a metal through which we have current flowing through it. How it is flowing? We have a switch, and this switch is off. We have a power, and the current will flow from here to here, from here. The path is like this, and this again, this can return, and this. So basically, we have a whenever there is a current in a conductor, and if I placed a current in magnetic field. What is a magnetic field? Means I have a magnet, and there are two poles of a magnet. We place it between those two poles. You will see that there is a magnetic flux. Flux means some sort of a energy which is flowing from north to south. So this is the flux, and whenever there is a flux and a current carrying conductor is placed in it, it will experience a force, and due to this force, this conductor will move in this direction. Let's say it is moving in this direction. Okay, so this is the basic law of the DC motor, and with this we have a motion. Now, but this is understandable because we know the Fleming's left hand rule, Fleming's right hand rule, how the force will act. But what about the mathematics? Because without mathematics, we are not able to understand and we are not able to develop the robot. So that is why the topic is robot control. So we have a force which has the following ex expression, and we have a torque we have which has the following expression, and this expression simply says that the torque is directly proportional to the current, because if we increase the current, it will experience a more force, and since it has a more force, therefore it will have a more torque. So this is the basic fundamental of a DC motor. And also, due to there is an inherent property in the conductor that whenever they are placed in a electric field and current is flowing, they also oppose the motion, because of the, you can see it as a Newton's third law. Whenever there is an action, opposite reaction is there. But they try to make another force that is called the back EMF. And this, due to this back EMF, we have a little bit, not exactly total force, but a force less than the actual force because of the back EMF. So this is the DC motor concept, and these are the equations. I'm again not going into the details. I hope these slides will help you to make understand what actually is the DC motor. So again, we have a Kirchhoff's law. Kirchhoff's law means how the current and voltage in a circuit will actually flow. So we have these RLC circuit, and we will apply the voltage and current rules, and we will write the equations. So these are very simple equations. I hope at an instant you see and you get frightened, but you need not to worry about it. If you understand the Kirchhoff's law, then they are the very basic equations. So next we talk about the robot model. So because I have a DC motor, and this DC motor will rotate. So whenever there is a rotation, whenever there is a motion, we have a laws of motion. And we simply write the laws of motion. And these laws of motions are very obvious. What are the force in one direction? What are the forces in other directions? And we will try to balance it. And with those equations, you will understand how the motion actually covers. So how the system, how the link move when we apply a voltage. So these are the two equations which help you to understand how much voltage will you give to a DC motor so that my robot arm will move from one point to the another point. If you don't know how much voltage has to be given, then the robot may collapse. So that is why we need the mathematics of this. So based on these two equations, we have a differentiations and integration parts, and which actually make you frightened. So you need not to worry about it. We have a wonderful tool called Laplace transform. I hope this Laplace transform you will be able to understand. Let me try to make you understand how I can, in a very simple way, I can tell you about the Laplace transform. So, and very important Laplace transform. This is a mathematical tool. And suppose I have a function ft, and then we have a function ft, and we have a function ft which may contain a differential equation, which may contain integration, which may contain differentiations. So how you will solve these typical mathematical equations? We have a Laplace transform. What it is? We have a function which is of time, because everything is in time. Why? Whenever you switch on the motor will rotate with respect to time. And since it is rotating with respect to time, therefore we have a function, and that function will change with respect to time. That is why we take everything in time and we convert it into a frequency. So rather than moving towards a frequency, we say that I will convert this function into another domain, which I called it as f, and t is replaced with s, where s is a complex variable. So it has some real and imaginary parts, and this is fs. But what actually is fs? How you will convert ft into fs? So whenever you want fs, so fs is nothing this, and fs is means Laplace transform of the ft. So this is the symbol of Laplace, and this is ft. But what actually it is? So it is an operator, just like a plus or minus. If I write it like italics L here, then it is a FT. So we have given an FS. We will get the FS. But what is the mathematical expression of FS? FS is FT. Then we have multiply it with e raised to the power st, and we have dt. So we have function ft. First we multiply it with the e raised to the power minus st, then integrate it from 0 to infinity. So whenever you integrate it using the mathematics, whatever the function will be, you will get a function in terms of s, and that is my Laplace transform. So this is a Laplace transform. So without doing much multiplication and subtraction or integration, we have some ready-made tools. What ready-made tools are? If we have a function f, if we multiply it with the constant k, then the constant k will be outside and it will be fs. Then If we have two functions, we take the Laplace of two functions, means the individual addition of the two Laplace transforms. If we have a differentiation, then if we take the Laplace transform of differentiation, then it is S into Fs minus F0 plus minus. And since we are talking that everything is in rest when t is equal to 0, so this is 0. So whenever we have a differentiation, we simply write it as an S into Fs. And we forget about what actually f is. We'll see it in the later part. Next, we have, if we have a double derivative here, then what we will do? We will do it as an s square fs minus f as 0. It will again be 0 because everything at t equal to 0 is 0. So at 0 plus or minus it is 0, again it is 0. So we have simple s square fs because we have taken initial conditions as 0. So whenever we have a differentiation, we simply write it as SFS. When we have a double derivative, we will write it as a S square Fs. So with this, we have these two equations, and because we have these two equations, we will try to use the Laplace transform of this. So whenever we try to do the Laplace transform, what we will get? Here we have a L, which is constant. This will be, because it is I, we will make it as a capital IS, and it is derivative, we call it as S plus R into IS, and it is V, which I call it as VS, minus KB. This is theta and derivative, so derivative is S. Theta I call it as theta M into S. So I make it into a Laplace transform. For this, I put it A. It is double derivative. It means S square theta M S plus M S theta M is equal to Km IS minus 1 upon R into tau. So these two are the equations. And now we have, instead of using the time domain, we are using the S domain. And with these two mathematical equations, we draw the block diagram. How we draw the block diagram? You can again see here the main voltage which you are giving to a DC motor. Because of this voltage, I have a DC motor which will run. It will start moving in an angular motion, and the angular motion is represented by the theta m, right? So I have voltage V, and the output is my angular motion. So the angular motion is theta m. So I have given a voltage to a DC motor, and I am getting a output which is an angular motion. And if you use these two equations, you can simply draw this block diagram. Okay, so this is my block diagram. So here we have,
बच्चों को कैसे समझाएंगे यार, इनको कुछ भी समझा रहे हैं.
so this is my basic DC motor, and this is my DC motor circuit, and this is my angular motion. So this is the motion part, and this is DC motor circuit part. So basically now you will understand that there are two parts in a robot. One is motor, the other is the link. So link is basically this part, and this is my motor. So motor is this part. So whenever you will use these two equations, you can see that this equation can be simply written in this form of block diagram. If you try to solve it, you can easily get, with the help of these two equations, you will get this diagram. So basically my target is not to understand these parts. This is only for the faculty members. The option is, I have a motor, I have a robot, and basically I am giving it the power, which is voltage, and I am getting an angle theta. And what inside is this part. This is for the faculty members, for the students to understand what actually inside. So this is basically the circuit part of it. So actually robot is, you will give a power, voltage V, and you will get a motion, that is a theta. Okay. So with this, you can see that what is the relation between these two. I mean, what is the relation between V and theta? You know that V and theta relation in time domain is this. These two relationships. If we talk in the Laplace transform, then if you use these two equations, this equation and this equation, and you will see that the relation between V and theta will be given by this term. If you solve the equation, you will get this. It means this is a voltage and this is the angle, and this is a constant type. You instantly, initially, you can understand it as a constant. So for the theta m s, if I say it is a constant capital K, then theta m K into Vs. So if you give 5 volt and if K value is 2, so you will get 10-degree motion. So you can understand that if I want to move it to the 10-degree, then I have to give a voltage of 5 volt. So this is the transfer function. That means how you have an input-output relationship. These are the input-output relationships which you have to understand. And I'm not moving towards the very mathematics part. If you are interested, you can easily see the mathematics and you will understand what actually it is. Now coming to the control part. Now you have understand what is the robot dynamics, how my robot will move if I will give a voltage, and how it will react when I will give a voltage and the angle it will cover. Now suppose I want that I give 5 volt, the robot should move 10-degree angle. But how you will actually make the robot to work like this? So we have a control. It means you have to design certain circuits which will understand your objective and will behave accordingly, right? So we have a robot control. So in a robot control, this is a very basic diagram. Let us understand what actually it is. So we have a process. Process means the thing which we want to control, that is arm. We have a robot arm. Robot arm is actually actuated with a DC motor, because when motor will move, then robot arm will work. So who will going to give the voltage to the motor? It will be given by a controller. So controller may be a power supply. It will be. But how much power supply he will give? He will give according to your set point. What do you mean by set point? Set point means desired objective. So suppose I want that my rotor should move 10-degree. So controller will actually understand the 10-degree and it will give voltage accordingly to the motor, and motor will move the robot arm and you will get a 10-degree. Okay. So, but how you understand that whether the motion is actually the 10-degree? So you must measure this 10-degree. And how you will measure it? With the help of a sensor, or we have a different type of sensor which will actually understand the angle. So for example, we have a potentiometer which will actually cover the uh, angular motion and convert it into a voltage, and this voltage will be given to this block, and this block will compare. What do you mean by compare? Here we have an output, because the position is giving the output. Here we have a desired objective. If we see that the desired objective and output are equal, then because it is plus and minus, it means they will measure the error. If the error is zero, it means the desired objective or the output is perfectly equal to the desired set point. If the set point is equal to the output, it means I don't have any error. It means controller is, whatever the controller is giving the voltage, it will actually give the same voltage to the motor so that it will run properly. If there is an error, it means, let's say here I am getting a 5-degree. So there is a difference of 5-degree here because I have set the 10 and output is 5, so it is 5-degree. So 5-degree is my error. So controller will understand, oh, there is a 5-degree error. Now I will increase the voltage. So increase the voltage and it will give an increased voltage to the motor, and motor will run the R. All right. So this is basically the fundamental diagram of the robot control, or we call it as a feedback control. So in a robot, you must know the dynamics, you must know the feedback control. Now the concept is how you will design a controller. Let's talk about the controller. Also, one more thing, we have a disturbance. What do you mean by disturbance? Disturbance means suddenly a wind will blow. So it will disturb the motion of a road, of an arm. So again, this is a disturbance. If I want to move in particular one direction and it is not moving in that particular direction because of the wind, then we call it as a disturbance is happening and we are forgetting our track. So we are maintaining the tracking problem. So this is a tracking problem. Second is the regulation problem. Regulation problem means if I want to make the system to to be upright. For example, we have a dish TV in our houses, and in dish TV, if the wind is blowing, then the angle of the dish TV will move. Okay, so the angle will disturb, but it has to be in a particular alignment. So every time I have to maintain that particular alignment. So there must be a regulation over here and it will remain in that particular direction. So this is called the regulation problem. So here we in the robot, we have a tracking problem. The other is my regulation problem. So these are two goals in the robot control. Okay. So the control mechanism, I talk you in a very simple way that what actually it is. So I am skipping this slide and let's talk about the controller, how you will design a controller. So the controller is my PID controller. Maybe you have know the word PID or not, but I will tell you PID is a very basic controller and it is highly used in the industries. Almost 90% of the industries use PID till date. So what is a PID? We have a plant or a process and this is my controller. But the controller is made up of three parts. One is P controller. Here we have an error. I told you there is an error. Error will be multiplied by some constant called Kp. So it is the error is basically multiplied by some constant. So there is one part. The same error is integrated throughout the motion. We integrate it. Integrate means we sum it and multiply with some constant. Again, we get some signal over here. The same error is differentiated and multiplied with KD. So we got the another signal. And these three signals will be added and then you add these three signals and give to the plant. So this is called PID. So P stands for proportional. This is I integral and this is derivative. This is D. So one part will multiply with simple constant. The other part will integrate the error. The third part will make a derivation of this error. So what do you mean by integration? Integration means it will sum up all the errors so that there is no any steady state error. We have a differentiation of an error. Differentiation means rate of change. So you will the controller will understand how the error is going to change. So it will sense the pattern of change of the error. Integrator will collect all the errors and proportional will simply amplify the error. So these are three parts. And if we together add it, these three signals, we get a PID controller. So this is the PID controller part, and I hope we have to use these PID. So the main part is the tuning. What do you mean by tuning? Tuning means how we select KP, KI, and KD terms. So KP, KI, and KD terms will be selected by some tuning methodologies. So these are the PID parameters, and I tell you what actually the P controller is, I controller is, and the D controller is. You can read it by the slide and how you will select the controller tuning. So the controller tuning for this you can refer to my work which have been some published in 3 journals and there you will understand how you can select the particular value of Kp, Ki and Kd so that you have a perfect tracking. Perfect tracking means if you want that the angle of the rotor should move or angle of a robot should move 10 degree, then it will perfectly move to the 10 degree. Okay, so these are some glimpse of the PID controller. Let's do how whether really it will work or not. So we have in the previous slide talked about the transfer functions, and now the transfer function, which is nothing but here you can see that there is a relation between angle and the voltage, and this is my controller, which is a PID controller. I selected my KP, KI, and KD values and built a PID controller. So this PID controller is my MATLAB simulation. In the MATLAB software, I did these simulations, and you will see what I do is I give the set point as 1 degree, 1 radian. It means if I want that my robot should move 1 radian. Sorry, it is not degree, 1 radian. So the output should be angle should move to the 1 radian perfectly. Let's see if I am not using the PID controller properly. So this is my response. You can see I have given my output should be 1. That means it should be 1 degree. It should move 1 degree, but it is not moving 1 degree. Initially it is 0, then it goes to 2, then again it's moved down to 0, and again it moves. So it is like a fluctuations in the robotic arm. So these are fluctuations. Why these are fluctuations? Because we are not actually tuning the PID controller properly. All right. So that is why we call it, these are the fluctuation. But if we tune the PID controller properly, then by selecting these particular values, I saw that initially my angle starts from 0, it increases, again it increases, it moves maximum to 1.3, and then it goes down slowly, and again it is settling to one particular point. And if you see, this particular point is 1 degree or 1 radian, sorry. So it means finally I am getting an angle of 1 radian in a motion with the help of a DC motor using the PID controller. So I think if you are able to tune PID controller, then you are able to understand how you can build a better robot which can exactly follow your commands. So the essential ingredient is PID controller. Now, coming to the future of the robotics, the next future is the artificial intelligence. I hope, because during the talk I saw some comments, and the faculty members were a little bit frightened to see the mathematics. So in order to replace these particular typical mathematics, we are using the artificial intelligence. So artificial intelligence completely remove the mathematics. How it is removing the mathematics? Because you know that artificial intelligence exactly work like the mind. If we able to understand that this is purple color and this is green color. So whenever I will give a green color, my robot will say it is a green color. When I will say I will give a robot purple color, then it will give a purple color. So it means I will have a memory in my robot, and I have feed every cause and effects. So with the help of every cause and effects, I am able to make a memory in the robot, and using that memory, it will not solve any mathematics. It will just see the input. And yes, for this input, the robot know that particular output will be there. So based on those selection of memories and selection of the data, it will give the output accordingly. So this is called machine learning. So the next concept and the people are working on, which is called the machine learning, because the machine learning actually depend upon the data. So you have to give a lot of data to the system, and system will have a memory. It will store that particular data, and corresponding to every data, he have a memory where the output is stored. So you actually have to map the input output with the help of data. So that is called data driven control. So the next one, or the future scope, is the data driven. And since we are working on the data, so there may be chances that some notorious people will hack the data, or they may disturb the data. So it means I need a database security, and for that database security I need some technology, and that technology is called the blockchain. So the people are working on the artificial intelligence and the blockchain to actually see the future of the robotics. So I think this is all about the robotics. And since because you are the school faculty members, most of them, so I request you all to be updated to the following website, that is the robots.ieee.org, where you will see thousands of robots of different types, where you will understand how the robot should look like, what is the basic type of robots which you are able to ask your student to build it, and you can understand those activities also, and what is actually going in the recent trends in the robotics. So I hope you have able to understand the robot control terminologies in this session. So that is all from my sides.
Audience, do you have
Thank you
questions?
so much, sir, for such a wonderful session.
Yeah, thank you.
Uh, Participants, if you have any question, you can ask from the sir.
Sir,
If
whatever
any
you
of the
explained,
participants is having any question,
ma'am, I want to ask, whatever
okay.
sir explain all theorems, and also how can I explain from class 6 to class 10th students, sir, ma'am?
See, for a class 6 to 8th student, you need not to explain these theorems. You simply have to give the glimpse of the robot. So for this, if you want to build an experiment on the robots, then first you must have a PID controller which is easily available in the market or in the robotics websites. So from there you can see the PID controller. You have a robot arm. You can link them and you can give some commands so that the robot arm will move. So don't worry about 6 to 10. But however, for the 10th plus, they must be knowing the Kirchhoff law.
Uh,
So
10 plus students
yeah.
are not in my school, sir. Only 6 to 10.
Okay.
That's why I'm here,
Yeah.
sir.
Okay. So anyways, I think you should visit the website robot.ieee.org, where you have a
Okay,
very
sir.
fundamentals of the robotics, and you can
One
learn all
basic
those
question,
over.
sir. One basic question, sir.
Yes.
For control, for PID controller, we must know all these theorems, Laplace theorem, Kirchhoff law, so many theorems
Yes.
you have taught, sir. So
Yes.
to
Yes.
control the PID, we must know that theorem.
Definitely true. Very true. So that is why I give a basic flavor of the tuning of a PID controller. Those who are interested, they can move on to this work.
Okay, thank you, sir.
Thank you so much, sir, for such a wonderful session. Now, I would like to call Mr. Yogesh for vote of thanks.
Okay, ma'am. The Thapar Institute of Engineering and Technology, Patiala, Punjab. Each topic was robot control. Its contents: automation technology. How do we perform automation? Robot and automated machines. Beginning beginning of robot, and three laws of robotics. Are robots are really necessary? The full form of IEEE, International of Electrical and Electronics Engineering. It tells us about the robot is essential for COVID-19 situation. Robot is used as a ward boy in a hospital, COVID-19 hospital, to take the medicines from one place to another place, and contact-free recording of patients. And he tells about us the few definitions such as process, actuator, and DC motor, etc. Actuators is nothing but the principle of operation of permanent magnet DC motor. He drive the expressions for EMF, electromotive force and torque, etc. and tells about Laplace transform. A Laplace transform is the tools that solve the differential equation, or it may convert from time domain to frequency domain, and by taking the Laplace inverse, it converts from frequency domain to time domains, and also tells about the features of robotics in nowadays. Now, thank you, Dr. Sahaj Saxena sir, and all the participants. Thank you very much.
Thank you.
Thank you so much, Saxena sir, Dr. Saxena sir, for such a wonderful session. Now, it's time to take a rest for the day, as you all are spended a lot of time in this whole FTP. And we will meet tomorrow at sharp 10 o'clock.